Hello and welcome to Kent's video on significant figures. This is part one. It's a two-part video series on significant figures. This first part is an introduction as to what significant figures are and how they're used in a measurement. This video is geared mostly for AP Chemistry, AP Physics students, where we use significant figures extensively throughout the year. Make sure you've read the book on significant figures. Both those are in chapter one of each book respectively. And make sure you know significant figures for the first exam. We do use them all the time throughout the year, so you never have to ask, do we pay attention to significant figures? The answer is always yes, especially during labs on any type of measurement. So basically, let's get right down to it. What are significant figures? What it has to deal with is the precision of the instrument that you're using is going to determine the number of digits that you list in a measurement. For example, a very expensive analytical balance in a chemistry room might have 4 or 5 digits past the decimal when it gives the mass of an object. Whereas a ruler that you use to measure the length of an object might only have 2 or 3 digits in its answer because the precision of those two instruments are very different. So when we do calculations, we can only list our final answer with the number of significant figures for the least precise instrument that we used, or the least precise measurement. That's the basic rule with significant figures. So um, just a little side note here. I know significant figures aren't the most exciting thing in the world. It's kind of a dry topic, but it is a very important topic. Otherwise, I wouldn't be making a video on this. So with that said, let's jump right in. So I've got two rulers drawn here. One ruler is definitely more precise than the other one. And the rule to follow when making a measurement is the last digit that you list is always an estimate, and it's always assumed that that was an estimate. So when I look at this measurement over here where the green arrow is, so over here, so I know it's past 17.6 centimeters. So without a doubt, I can write, let me make sure I get the right mark here. Okay, I can write 17.6 centimeters. But then the last digit I list is an estimate, and it's known to be an estimate. It's assumed to be an estimate. If you just list it like that, that's not correct. You actually need to put in that last digit. So to me, it kind of looks like it's in between the 0.6 and the 0.7, maybe a little bit closer to the 0.6. So I'm going to put this here. But once again, the key thing is that's uncertain. Okay, so it could very well be 17.65, or it could be 17.66. Okay, it's in that range there, but it's assumed to be that last digit is an estimate. So with this one down here, it's not as precise. So we have 17 to 18. So I'm going to list this as 17.6 centimeters. It's assumed that last digit was an estimate. Okay, it could very well be, someone could argue with me, it looks closer to 17.7. Okay, make sure that's centimeters there. Who's to say who's right, who's wrong? Once again, that last digit is a best guess estimate. But what you see here is the difference in these two measurements here. This measurement has 3 significant figures. This measurement has 4 significant figures. It tells the scientist or engineer who's looking at those measurements the precision of the instrument that was used to make those measurements. And it's very important in research papers to verify data. So we don't just list numbers randomly. They actually mean something. And once again, that last digit's assumed to be an estimate. So remember that when you're looking at a graduated cylinder or a burette, and you see the digits and you're reading the meniscus on there, you give that last digit as an estimate here. So if I scroll down here, students in AP Chemistry in Chapter 1, you have a problem in your homework number 82. And you're going to find out in that Zumdahl book, they're very good at creating questions that basically the chapter will teach you to walk forward and the question will test you to walk backwards. So what we did up here is I gave you the instrument and you had to give the measurement. But what they want you to do in question 82 is basically they're going to give you the measurement and they want you to draw the instrument or the gradations on the glassware that would correspond to that. So I'm going to create a different problem here so it's not identical to 82, but it's the same flavor of the problem. So let's say you had to create a glassware or graduated cylinder or some kind of device, and you measured 145.6 milliliters. So 145.6 milliliters. What would that glassware look like? So let's say I'm drawing side of a large graduated cylinder or something like that. So once again, you got to understand that's an estimate. So there's not going to be gradations on the glassware going 0.4, 0.5, 0.6, because then it wouldn't be an estimate. So your digits are actually going to look like this on your glassware. So it's going to be 144, 145, 146, and so on and so forth. You get the idea. So when you had water in there, I'm not going to actually draw the meniscus. This device isn't accurate enough, but the water line with the meniscus would have been somewhere between, let's see, after 145, it would have been somewhere in here, but that water line would have been an estimate. Okay, so that's what the gradations on that glassware would look like. Let's try one more here. Let's say you have a measurement and it's listed as 24 milliliters. What would the gradations on that glassware look like? Well, remember that 4 is an estimate. So this is going to be more like a beaker. So it's not going to be as precise as the last instrument you just drew here. So this might be 10 milliliters, 20 milliliters, 30 milliliters. So remember that in your summer homework assignment for AP Chemistry, the instrument that you're using, how many significant figures. So 24 milliliters, of course, is going to be somewhere like here. But it could be 25, could be 23. That last one's an estimate. And you can see the precision of this instrument is very different than the precision of this instrument from the gradations on the glassware and the number of significant figures given in each measurement. So that's a brief introduction to some of the basics on significant figures. In the second video, we're going to go into much more detail in terms of how do you count significant figures with some complex numbers. There's a couple of rules to follow. And then what rules do you follow when you're adding and subtracting measurements and when you're multiplying and dividing measurements. There's 2 different sets of rules for each of those. So we'll be going over those in the second video. So I hope this was a good introduction, and we'll follow up on the second video there. Thank you very much.